Recording has started. So I want to talk about init and what is meaning of init in Python. What does it do? So this is what you're going to do. Init is a function. This function helps us to, let me write it out. Init is a keyword. Then so points. Remove this. Now come here for now. We put self. I will come back to the explanation of this word self. But let's talk about init. Init is the first thing that will be called whenever you create a new instance of a class. We call this init. In other programming languages it is called constructor, and I think even in Python it's called constructor. This init is called constructor. This constructor is actually the one responsible for creating an object out of the class. So whether we write it there or not, it actually has init. But maybe you now want to do other things other than what it is inbuilt, then you can now put it inside this init. Again, if you want to do anything, immediately you create an object out of a class, then you put that thing inside this init. I want to do something, immediately I'm trying to create an object out of a class. Remember I said it is this init. This init is the one responsible for constructing an object out of the class. We call it constructor because it is the one responsible for constructing an object out of the class. So because it's the one responsible for it, whenever we are about to create an object, maybe you want to do something, when you want to create an object out of the class, then you put it inside the init, and that's what you are doing here. Do you understand it, sir?
So what, in essence, whether we put the init or not, it is like a default. It's always there.
Yes, it is there. It is always there.
And it's the constructor.
Yes. But maybe you now want to do some other things other than what is simply doing. Then you can now put it inside the init. What this is going to do is, at this point that we are creating an object out of the class, is going to run all the codes inside the init. Normally, if I want to display good evening, I have to call on this function another for good evening, good evening. Let's say good night. Let me just change this to good night. So normally if I want to display good evening, I have to call on function another func. But when you are dealing with init, you don't need to call on it. It's going to be called at this point. At that point, when you're about to create an object out of the class, then all the codes inside init will be executed. Do you understand it? So if I leave this, let's say if I have this will print good night.
Sorry.
Yes, sir.
The code in init is good night. Am I right?
Yes, sir.
So I'm trying to look at something. So if you want to call good evening now, and good evening is under another func.
Yes. I have to say
you don't need to put
another func. Yes.
You don't need to trigger it here.
Yes.
So fight is already in it, am I right?
Yes.
Okay.
So this we call good evening. But if I want to call on good night, I don't need to call on b dots init like this. No. I only need to write this. At this point that we are trying to create an object out of the class, whatever code we have inside the constructor will be executed. Do you get it?
Okay. So because you have triggered, you've called b is equals to Taiwo, and the parentheses. it will naturally bring about everything inside the init. Am I right?
Yes. So that makes it different from other functions. And when a function is inside a class like this, we call it methods. So this is a method, this is another method, and this is another method. But the idea of init is that at that point, when you are creating an object out of the class, the code inside it will be executed. Let's run it and see if everything is working fine. So we have this good night. Even though we are not calling on init anywhere in our code, but this at this point, when you try to create an object out of the class, the constructor will definitely run all the the constructor will run all the codes inside the constructor, inside itself. This is the constructor. So all the codes within the constructor will be executed. Let's proceed. Next.
Sorry.
Yes.
I noticed the results showed only good night.
Yes, it will just show good night because that is the only thing we have inside init.
So it means if we actually now need the other function, the other methods, like my func and another func, we have to trigger it.
Yes, we have to trigger them.
Okay.
Func. So
Okay.
this will,
So we don't need to trigger init. Init is already inside B.
is it?
We don't need to trigger init. Init is already
Yes.
inside the B.
Yes, is a keyword. This word init is a keyword.
All right.
And
Thank you.
like I said, it is the name is actually constructor. It is in fact it is the one responsible for constructing an object out of the class. So some things have been written inside it so that whenever you call on this, it will definitely go to the constructor. Whether it is written there or not, there is a constructor. So it will definitely go to the constructor. The constructor now is the one responsible for creating object out of the class. So that's why it is called constructor, because it is the one that will construct an object out of the class. So that's why it will always be triggered at this point. Do you understand it?
Yes. Thank you.
Okay, you're welcome. So let's proceed. Let's talk about this self. But before we discuss self, I'll do something. I'll put a parameter here. Maybe I want to say, hello, Taye, how are you doing? So I can do something like this, hello. So this will give me hello plus name. How are you doing? So this will give me hello Taye, how are you doing? So let's call on this my func. So I'll come here, I'll say b dot my func. Now I have two arguments here. I want to pass two parameters. Like normally I should pass two parameters since I have two arguments here, but it's not like that. This is a function, right? But this function is now within a class. The first parameter of a class itself, I will explain this self, but I want you to know that when you pass anything here, let's say try, is not passed to the first parameter, it will pass to the second parameter. This can be anything, but this time will not be sent as the value of a. No, it will be sent to the second one. Let's say I have two values here. Let's say software, and I come here and I put anything. This tile will be passed to this second one. This software will be passed to the third one. The thing is, whenever you have a function like this inside a class, the first argument is actually meant to perform a specific purpose. There is something it is meant to do. Again, when you have a function like this inside a class, the first argument of that function has a special feature, has something special it is meant to do. So that when you want to pass parameter, the first parameter you are passing, it goes to the second argument. The second parameter goes to the third because there is this first one is already reserved for a specific purpose. Do you understand it?
Yeah. So it means the first parameter is like a default, doing
Yes.
another function or automatically.
Yes. Yes. You get it. In fact, if I don't put anything, this will throw back an error because it expects that at least it must have one, which is the default, like it already has a purpose. We will discuss that one very soon. So if I remove this will throw back an error telling me that I have to put at least one argument there. Do you understand it?
Yes.
Okay. So let's try to do this first. I'll just run this so that we can see the error together. I'll remove this name for now. And so if I try to call on my func like this, it will throw back an error. It's throwing back an error. Even though I'm not passing anything here and I'm not passing anything there, it will throw back an error because this naturally expect at least one argument. It can be anything. It can be anything. So this will work fine now. Good. This will work fine. Then whatever I now put here, whatever I put here, we now go to the second one. So these gems will be sent to the second one. Let's now discuss the first argument, what it represents. The first argument here represents this class itself. I come again. The first argument represents the whole class. That is why it is usually called self. You can put anything, but the convention is to use the word self, but it can be anything. But whatever you put here, let's say if I put A, this A represents this Taiwo. This self represents this Taiwo. This self represents this Taiwo. So the first argument of every method inside a class represents the class itself. Do you get it, sir?
Yes, yes.
Okay. So the first method, the first argument inside the method of a class. You know, I said this is called method. If it's inside a class, we don't call it functions again. We call it method. So the first argument inside the method of a class represents the class itself. So this is like putting Taiwo here. This is like putting Taiwo here. This is like putting Taiwo here. The whole class. Now, what is the significance of that? Let's follow convention and put the word self. So this self now gives me access to everything inside this class. Remember, this self represents the whole class. So it now gives me access to every other thing inside the class. So if I want to, I think someone wants to join. So if I want to print out this software, I can, inside this my func, I can say print self dot department. Do you get it? Because this self represents the whole class, so I can say print self dot department. Do you understand?
So that means we don't even need to write print Taiwo dot department.
That's if I want to call it inside this class itself. You know, I'm still within this class. This is outside the class. Everything else
I
is
understand.
within the class. Okay. Do you understand it, sir?
Yes, yes.
So this self represents this whole class. So I can say self.department and it will print software. So let's run it. So I can remove this. So when I call on this function here like this, it automatically run all the codes here, and it will print software and also print hello, how are you doing? Let's run it together. Software. Let's take it a step further. We can do something here. We can say,
Sorry, sir.
yes,
Sorry. So in another word, self is like a global variable.
yeah, hey, yes, it's like a global variable within that class.
Yeah. Yeah.
You're right. So I can also come here and do something. I can say self dot another func. So what will happen here is this: when I call on my func here like this, it will run all the codes here, meaning it will print software. It will now call on this function, so it will print good evening. Then it will now print hello, how are you doing? Do you understand?
Yes. Yes.
Okay. So that's on it. Software, good evening, hello, how are you doing? So with this self, we have access to all the properties. These are properties. This is one of the properties, and all the methods inside this class. But that's not all. In fact, the primary reason why my own thoughts. The primary reason why this self was introduced, we are yet to discuss it. Let's go into that. The primary reason why this self was introduced, we will discuss it now. So far, this class is not flexible. I think someone wants to join. So far, this class is not flexible. It's not flexible. We want to make it more flexible. Remember, a class is like a blueprint. I liken it to a building plan in a GRA. Now, the fact that, well, houses in GRA are alike, they look alike, but they are not always exactly the same. Yes, they look alike, but not always exactly the same, meaning that there can still be some variations. Now, that is what we want to introduce to our class. With the way our code is currently, everything, if whenever we create, let's create something else. Let's say C equals to Taiwan. Let's say C equals to Taiwan. This C and this B, they will be exactly the same thing presently. But we want to create some flexibilities so that we're able to make some tweaks to this B and make it a bit different from C. But they will still have the same structure. They will have the same structure, but not totally the same. That will make our codes more flexible. Let's do that. So what I want to do is this. I will take the software out of this place and I'll bring it in here. Now, if I say department equals to software, department equals to software. This department is a local variable to this init, meaning I won't be able to use it here. I won't be able to use it here, but that's not what we want. I want it to behave exactly the way it was when it was here. When it was here, we were able to just come here and say self.department, and we were able to use it here. So I want it to behave exactly the same way, so that all these functions, or these methods, this method and this method, they were able to use this department. So if I just come here and put it here, that will not give me what I want, because it will just be a local variable to this. So instead, I will now say self.department equals to software. What you have here is the same as coming here and saying department equals to software. This line and this line will give us the same results, because in both instances we are setting department directly on this class. Do you get it? Are we together?
Yes.
Okay. So I will quickly do a brief recap for this that just joined, but I will be done with this place. Once I'm done with this part, I will do a brief recap. This self department, we set software directly on Taiwo because this self represents this class. So putting it here like this and putting it here like this will give us the same results. Now, why then should we stress ourselves by putting it here? Why not here? So let me quickly do a recap to put everybody at the same level. In our last class, we talked about a class, then we talked about constructor, then I think we were about to start constructor when we ended our class. So today's class, we are starting with constructor. Now, this is a constructor. This word in it is a constructor. What is a constructor? A constructor is the one that helps us to construct an object out of a class. One. Two is the, but I think that's just that's the definition of what a constructor is. But a better way to view it is this: a constructor is that function that will always be called whenever you try to create an object out of a class. So, and that's what we are doing here. We are creating, if you follow our last class, you will realize at this point we are creating an object out of a class and we are assigning that object to variable b. Instantly, it will run all the codes inside the constructor. So it's going to do this. If I have something here like this, print I. So at this point, this will print I. At this point also, this will also print I. So a constructor is that method that will always be called at the point you are instantiating a new instance of a class. This is a new instance of a class. At that point, the constructor will be triggered. Having discussed constructor, I want to discuss the meaning of this word self. Every function or every method that we add to our class, we always add this word self. This self is not a must to use self, it can be anything. But all the methods inside the class always have its first argument. This is the first argument. It always has its first argument as the class. What do I mean? The first argument of all methods in the class represents the class itself. So this A represents this Taiwo itself. It represents the O class. This self represents this Taiwo. This self represents this Taiwo. So the first argument inside this method represents the class itself. So that gives us access to some things or to everything on that class, everything we have inside that class. This A now represents this class. So we can come here and say we can come here and say A dot department. Since A represents Taiwo, then we can now say A dot department. A dot department will give us software. So next is we are taking this a step forward. So I think that's just a recap. Don't worry, after the class you can go to the video. If you have any question, then you can ask. So let's continue. I want to talk about the core reason why this self was introduced. It was mainly introduced to make this class more flexible. What does that mean? Now, I put department equals to software. I can also write the same thing by saying self.department equals to software. This line and this line will do the same thing. Well, you can ask this question: why not come here and say self, then copy this and paste it here? Does this line and this line mean the same thing? No, they don't mean the same thing. But this line and this line means the same thing. I will explain why these two, this and this, why they do not mean the same thing. Yet this and this means the same thing. Let's discuss that. For now, I will remove this constructor. I will also remove this line. I want to ask us a question. If I come here and I say b dot print b dot department, what will I say? Let me remove this too for now. If I say print b dot department, what will I say?
To bring an error.
Now it's just going to print is it none now? Like it's not going to see department on B. Okay, it's showing this error. Taiwo object has no article department. Now the reason is because I have not called on this function, and you know when you are yet to call on a method, all the codes inside that method will not be same. So because I'm yet to call on this, it's not seeing department on Taiwo. But if I come here and I say b dot my func, then I can now call on b dot department. This will work because on calling on this here, this function will help me to set software on this class. Then I can now print b dot department. Do you get it? Do you understand? So this is giving us software. Do you understand it?
Please come again. Please come again.
For now, I will remove this and I will run this. If I say this, there is no department on Taiwo, right? Abina. This is where I'm trying to set department on Taiwo. This function, my func, is the one responsible for setting departments on our class. But at this point, I'm here to call on this function, my func. I didn't call on that function, meaning that all the codes inside this place will be ignored until I call on that function. Abi? Are we together? Greatness Titi Kafayat Olamide. We are not talking.
We are together. But me, I don't understand, so I don't want to disturb the class until after you revise
After
it.
the class, you can
again.
go to the video. Okay, please. Do you understand this part? This
Yes.
self.department. This self is the one responsible. We are saying that on Taiwo, because self represents Taiwo now, it represents the whole class. We are saying that on Taiwo, create a property on it called department and let the value of that property be software. That is what we are doing with this thing. But unfortunately, this is inside a function. And because it's inside a function, we need to first call on that function before the codes within that function can be executed. And because we are not calling on the function here, meaning that the codes here will never be executed. Do you understand?
Yes.
So when we say b.department, there is no b anywhere because b represents an object created out of Taiwo and there is no department there. We've removed this line. So there is no department there. So this will throw back an error telling me that I can't see departments on this class. But when we now adjust this a bit by saying first column my func, b.myfunc. b.myfunc will run all the codes here, meaning that it will help us to create a property called department on self. It will help us to create a property called department on self, and that will, meaning that it will help us to create it on this Taiwo, and the value will be software. So after creating, we can now say b.department. So this will now give us software. Do you get the explanation?
Yes.
Okay. So this will give us software. Software. So, but if you put this here now, if you put this here, we don't need this line again. Oh. If we put this here, we don't need this line again because department is already directly inside Taiwo. So we can say be the department. This will give us software. We can now also do this. We can do this and remove this. Because the constructor is triggered at this point. The constructor is called here. So at this point, it will quickly help us to create departments directly on Taiwo. Self.department equals to software. So whether we put it here or we put it here, it will still give us the same result because the constructor is triggered on line 15. So at that point, it will quickly create departments on self. So that when you now come here and say print b.department, it will give us software. Do you understand? Are we together?
Yes.
Do you understand?
Yeah.
Again, for those of us that are just joining, know that this self represents this class. So this is like saying Taiwo.department equals to software. So what you are doing here is you are saying help us to create department on Taiwo and let the value be software. And I have already discussed that the constructor is triggered here. Let me remove this line, maybe this is confused. At this point, it will run all the codes inside the constructor, meaning if I have print hello world, if I run this code, I will see hello world. That's because the constructor will be triggered at this point when you try to create an object out of a class. So meaning that at that point also, it will quickly set the value of department as software. It will quickly set the value of department on this tile. Remember, this self represents the class itself. So it will quickly create a property called department on the class, and the value of that will be software. So that when I now come to this line and I say print b.department, I will say software without this, even without this second line, because this will do that for me. Do you get the explanation, or is confusing? If it's confusing, please let me know where you find confusing.
It's kind of confusing. You know, that self.department part.
Again, when you watch the video, you understand the meaning. But for now, just know that this self represents this Taiwo. So whenever you see self, know that you are referring to the class itself. Do you get it?
Yes.
Do you get it?
Yes.
Whenever you see self, just assume that,
Yes.
or just know that, oh, I'm referring to the O class. So this is like saying Taiwo.department equals to software. Do you get it, that part?
Yes. Yes.
Okay. That's the same thing happening here. Then we now have a special function called constructor, this init. And what it does is it will always be called upon whenever you try to create an object out of a class. Meaning that you don't come here and say b.init. No, you don't call on it like this. Instead, it is always called upon at this point. So meaning at this point, if you run all the codes here, and you are saying Taiwo.department equals to software. So it's going to help us to set software on this, on self. So at this point, self will have department, and the value of that will be software. Any question? Please, can we proceed?
Yes.
let's move on. Next thing is this. We know that this self-department will help us to set it. We now want to adjust it a bit, because you can ask this question: if this line, let me remove this line from now. If this line and this line we do the same thing, why then should we stress ourselves by putting it here? Why not just put it here? Now this answers it. That's what we want to do next. This is a function, and because it's a function, it can be parameterized, meaning I can put anything here. Let me just put a text called anything. So I can now say the value of departments equals to anything. I come again. I can put anything, meaning I will definitely pass a parameter to this. I will send a parameter to this. Then I can now say the self.departments equals to whatever I pass here. And as I explained at the beginning of this class, I said if I put name here and I say print name, ignore this for now, for the sake of those of us that are just joining. Let's look at this part. If I say b dot my phone and I pass, let's say Tolu here, this Tolu will be sent to this name and not to self, because this first one already has what it's doing in Python. This Tolu will be sent to name, so that when I say print name, this will print Tolu. That's why every method in a class must start with self. That's why you first put self as the first one. At least it must have one argument, which is the first, which stands for self. Then every other one now goes to the remaining. This Tolu goes to name. So when I come here and I say self and I put anything, I want to pass something here, and whatever I pass here will be sent as the value of self.department. Now there's a little problem. The problem is that at no point in my code am I calling on this. At no point in my code. So let's say I put hardware there. We know that this hardware will be sent to anything, but unfortunately we are not even calling on init at any point in our code. So how then do we pass this hardware to this anything if we are not calling on init at any point in our code? I come again. At no point in our code are we calling directly on init. So how then are we going to pass this hardware to anything if we are not going to call on init directly? Let's solve that problem. To solve that problem, we can do something. We can say, since the constructor, or that is the init, since it will be triggered here, we can pass a value here. So whatever value you pass here will be sent straight to the constructor, and it will pass to this anything. Do you understand? Whatever value you put here will be sent to this place. So it becomes the value of anything. So that self.department will now be anything, which is hardware. So this hardware will be sent as the value of anything. Then self.department will now be equals to the value of anything, which is hardware. So that makes it flexible. It makes it flexible. Hardware will be sent to anything. Then self.department will now be equals to anything, which is hardware. If I say print b.department, this print hardware. Hardware. And if I create a new variable called c, and I say c is I want it to be csc. This csc will be passed to anything, so that self.department will now be equals to csc. So if I say print c dot department, this will print CSC. So this is for B. The hardware is for B, the CSC is for C. So you will now realize that although B and C, they are both created from the same class, they are doing different things. So it has made our class a bit flexible. Now I realize that it seems we are lost at this point. Don't worry, we'll be stopping here today. Please ensure you watch this video before the next class, and please, I beg us, please don't come late in our next class. Please don't come late in our next class. It's part of those. In fact, that's what is responsible to what we are experiencing currently. We came late, and because of that, we've explained some things before we joined, and we are having issues catching up with those things that have been explained earlier. But before we go, let's do a recap. This is a class. Inside this class, you can have a method. This method, I can say hello func. So what do I want this function to do? I just want it to print hello world. So this is a class. I want to create a new instance of the class. Now if I say to create a new instance of the class, meaning I want to create an object out of the class, just put any variable here. Let me call it any variable, and I will just say equals to I will like this. So when I call on this, it will create an object out of this class. And even if this object has a property and I say the name is, let's say, James, so I can now say any variable dot name. This will give me James. To display the result, I can say print it out. Although this will throw back an error for one reason, it's expecting this to have something here. I will just put anything here. So I will come back to this. But then we are creating a new instance of a class, and that object now, this any variable is an object. It will have everything inside this class. So we can now say any variable dot name. This will print out James. If I want to call on this function, I will say any variable dot hello func. It will print hello world. Next is this. Instead of saying hello world, I want it to be hello school, like the name of the school. So I want to pass school here. So I can come here and say LoudTech. So this LoudTech is not going to be sent to this A. Everything we've learned so far, or before now, made us realize that this LoudTech will be sent to A. But I'm telling us at this point that because it is inside the class, this LoudTech will not be sent to A. Instead, it's expecting another variable here to take it. This first one already has what it's doing. The first argument of the method of the class already has what it's doing. So this LoudTech will be sent to the second one. So I can come here and say hello plus school. So this will now give me hello LoudTech. Now, what then is the purpose of this? This A represents this class itself. The first argument in all the methods will always represent the class. So this A represents this class itself. So inside this A now, since I know that this A represents the class, I can now say a.name. So this will give me James. If I say print a.name, it will bring James, because this A represents the O class. So I can access this inside it. Then talk about constructor. Print welcome. So what is a constructor? A constructor is just a function that will always be triggered at that point that you are trying to create an object out of the class at that point, not after. It is still at that same point that you are trying to. Meaning that, in fact, I can say you've not actually create, at that point when you are creating it, then the constructor will be triggered. In fact, ideally, it's actually the constructor that is really helping us with the creation. So the constructor, this is the constructor, will be triggered at this point. So when you run this, you'll be surprised that you will see welcome before other things here. You will see welcome before saying James. You will see welcome before saying hello, Laute. That's because the constructor will be triggered at this point. Oh, what's going on? Okay. Oh. Okay. So this welcome is before other things. It's before other things because it is triggered at this point. The constructor will be triggered at that point. Then next, we are now saying, our position to tell us that you can now say self.name equals to James. So that instead of putting the name here, you can choose to put it here, and both of them will give you the same result. Because the constructor is called at this particular point, then when you try to create this out instantly, if you quickly say self.name is James, then before doing other things, so you can now say any variable dot name. Even if I remove this here now, if I say any variable dot name, this will still give me James. That's because the constructor is triggered at this point. So instantly to quickly do this before coming to the next line. So we can now say that now makes this more flexible. I can now say, instead of putting this, I can say I can pass the James there. So, and I'll say this is name. So this dot, so that you will not think it is this one, I'll just say this is n. So this James will be sent to this n. This James will be sent to the, whatever you put inside the class name like this will be sent directly to the constructor, and it's sent to this n. So self.name will now be equals to James because n is James. If I create another variable, if I say variable k equals to Taiwo, and I put tt, this tt will be sent to this n, and self.name will be tt. So for k, if I say k, print k dot name, this will print tt. But if I say print any variable dot name, this will print James. So I think that's where we will stop tonight. In our next class, that will be on Thursday, we will discuss class inheritance. Any question? Please, if you understand today's explanation very well, say I.
I.
Okay. Mr. Tolo Lifer, please, are we together?
Yes, I.
Okay, greatness TT, do you understand? Okay, so we call it a day at this point. In our next class, please, I beg us, come early, 8:30 Nigerian time, 8:30. Thank you very much. Have a lovely night, sister. I will send the recordings to us. Then, before we go, our assignments. What's the progress?